Friends, this is the second part of the series on sprinklers. In the first part of this sprinkler, we have learnt about the sprinkler in general, uh, what types are there, and in this particular series, we will learn about how much and where the sprinkler systems are to be provided. I am VK Jan. Dear friends, this particular series of sprinkler, I have taken everything from National Building Code of India 2016, Part 4, Fire and Life Safety, and as per Class 3.4.8, Table number 23 and 24, automatic water sprinkler systems are mandatory in the following premises, occupancies, and situations. This we will learn in three different parts. The first one is why occupancy type, and out of that also the first one is residential buildings. The sprinkler shall be provided in high-rise residential buildings 15 meter or more in height as per National Building Code. Any building more than 15 meter is known as high-rise building, whereas in other worldwide other codes it is 35 meters. But in India they have taken it more than 15 meter. Now let us talk where this sprinkler are to be provided. In the group housing apartments where height is more than 15 meter, hostels, dormitories and boarding houses having height more than 15 meter. Dear friends, in case of educational building, that is schools, colleges and training institute, more than height 15 meter, and where the built up area is 5,000 square meter, uh, and hostels attached to the educational building if their height is more than 15 meter. So these three items are necessary for compulsorily to be provided. The next category is institutional buildings. Institutional building includes all those buildings where people are sent for some purpose, that is hospital, nursing homes of height more than 15 meter are having basements. The sprinklers are mandatory. In custodial institutions, that is jails, mental hospital, old age houses, and hostel used for medical stay for long-term care. Assembly buildings are those buildings where go for people in large number go for stay. The the occupancies like cinema halls, multiplexes, auditoria, theaters, exhibition halls, convention centers, and community hall. It is compulsory to provide a sprinkler if the occupant load is equal to or more than 3,000 persons, or where the built up area is 5000 square meter, or when height is more than 15 in both the above cases. In case of business buildings, sprinklers are mandatory to be provided in offices, IT buildings, banks, courts, administrative building. If the business building is more than 15 meter in height and basement is there and built area more than 5000 square meter. The next category is of storage buildings. Sprinklers are mandatory for provided in warehouses, cold storages, godowns, record rooms, or libraries with high fire load, especially when storage height is more than 3.6 meter and high fire load exists. Uh, Hitherto, we have included all occupancy type uh, except hazardous buildings. The second category is of special areas regardless of occupancies. That in either in the occupancy types either to discuss. In some areas, it is mandatory for basement any use except parking with special provisions. For covered car parks in high-rise buildings, electrical rooms more than 100 square meter, UPS or server rooms, HE room of large capacity, false ceiling spaces with heavy cabling, vertical shaft carrying services, refuse and garbage rooms, aquariums, especially in shopping malls. The third category is of height based requirement. It is very important. In all buildings more than 15 meter in height, this automatic sprinkler system is a must. Friends, from beginning to this slide, we have discussed the portions of the building where sprinkler are mandated and are compulsorily to be provided. Now, through this slide, I am going to tell you some obligatory exceptions where sprinkler systems shall not be provided. Grand salvage, grand winds, inside building farming, part of corn mill, distillery, makings of oil mills, ovens, hovels, and kilns in pottery, earthenware industry, brick, tile, and glass works, and areas and rooms are places where the water discharged from a sprinkler may pose a hazard. That means if you provide a sprinkler, automatic sprinkler, and it works, the surroundings will get damaged. Generally, sprinkler protection shall be considered for what need not be provided in following parts of building or plant. One stair spaces below stair headings, what not rooms above a stair. These are the below portions. Normally, people provide electrical switchboard there. And in lift wells, any part not provided with a sprinkler shall be separated by walls 225 mm brick or 1000 mm for concrete. Fire doors shall not be less than 1 hour in fire resistance. Friends, we are discussing about the area of the buildings where the fire water sprinkler need not be provided. The second category is of bathrooms, toilets and WC, but not the cloak rooms. Cloak rooms are the rooms provided for keeping your luggage if you are brought into that particular building. Any part not provided with a sprinkler protection shall be separated by walls 225 mm brick or 100 mm RCC. The fire door of not less than 1 hour in fire resistance in such cases. Third, rooms are compartments containing electrical power distribution apparatus such as switchgear and transformers and used for no other purposes. Any part not provided with sprinkler protection shall be separated by walls 225 mm brick or 100 mm RCC. Fire door not less than 1 hour in fire resistance shall be provided in opening of such walls. Fourth, in paper making machines, the undersides of the screens are of shields erected over the vat and where there is no fire hazard. Friends, I am going to present you the classification of occupancies based on hazard. As the water supply, pumping capacity and other features of the sprinkler installations depend not only on the size of the risk but also on its fire growth and spread potentialities. The risks are to be categorized under following classes for purpose of design of the installation. First one is light hazard class, second one is moderate hazard class, third one is high hazard class, and fourth is storage hazard. A broad classification of various occupancy is given in National Building Code otherwise. Friends, with my experience of 35 years in CPW, I will like to tell you that in most of the cases, more than 80%, these rules may be followed. It is on safer side to provide create a building like hospital and business buildings with a moderate hazard class design, and in such area side wall sprinklers shall be at provided for every 9 square meter area or part thereof. Similarly, for other type of sprinkler, this is 12 square meter. So remember 12 square meter, every 12 square meter or part thereof, you are supposed to provide a sprinkler. The sprinkler may be provided horizontally in different rows separated by following spacing. maximum distance between sprinkler on range pipe and between adjacent rows of sprinkler. For sidewall sprinkler, maximum 3.4 meter. Other type of sprinkler with standard spacing of 4 meter or so. With staggered spacing, sprinkler on ranges and can go up to 4.6 meter, and for adjacent road, the first row has to be 4.6 meter away from the wall. The next rows may be 4 meter if the area is more in case of large areas. So remember, in most of the cases, you have to provide the separation distance of 4 meter, and every adjacent row by 4 meter in large area starting from the first, which may be 4.6 meter away. Minimum spacing between sprinklers. Sprinklers shall not be provided at less than 2 meter except in locations where heat sensitive element of the sprinkler can be protected from wetting of the operation of the adjoining sprinkler by suitable vessels with prior approval. You can see figure 17 of National Building Code Part 4. Dear friends, through this particular slide, we are going to learn about the design density and AMAO, that means assumed maximum area of operation for fully hydraulically calculated or pre-calculated sprinkler systems. We'll see what these two different type of systems are there. First, let us see that in National Building Code, the design density and assumed maximum area of operation for various type of risk are as given in table 3, which provides light hazard design density has to be 2.25 liter per minute per square meter area of the occupancy, and assumed maximum area of operation, that is AMAO, in square meter about 84 square meter. In case of moderate, the design density has to be 5 liter per minute per square meter, and AMAO of 360, and for high 9 liter per minute per square meter and AMO of 260. So this figure you have to remember, particularly that for moderate. Friends, this is a very critical diagram as a part of our design work. You have to first see it for about a minute, and then I will talk about different parts of this diagram. This diagram has three different parts. First one tells you a vertical riser coming from ground floor and upper floors, and it may extend to basements also. So this is the vertical line in which control valve set is installed here, or man stop valve, to stop water in a particular area. Second important part of this is horizontal. There is a distribution pipe starting from here to here and then dropping to another portion of the that particular area. From this distribution pipe, we have risers slightly above, and they get divided in two range pipe systems. Uh, This is one series of range pipe. This is another series of range pipe, and we have sprinkler heads provided. So these are parallel lines, and this is the cross distribution pipeline dropping into another s- distribution system. This may be in man room, and this may be in drop ceiling portion of that particular room. So you can see that the several sprinkler heads are provided in a particular range, and range may be on both the side of the main distribution pipe. Main distribution pipe is this. This is drop portion of that rising system, and this portion is known as arm pipe, horizontal. These are all horizontal. This is horizontal. The only vertical portion is this, or this, or this. There are three verticals, this or this. Friends, this particular diagram shows you the arrangement vertically in in the rooms which are inclined with each other. S- And this may be drop portion of that. Friends, this particular diagram shows you two different part of horizontal part of sprinkler distribution, which are known as two end side with central feed. This is the central feed, and two end sides. This horizontal, all horizontal. This is not vertical, horizontal. Similarly, this may be central feed with both sides end feeds. These are the end feeds. This is the end feed, and it is on both the sides. Friends, these are the other two design diagrams in which three end feeds are there in this particular left hand side, fed by one central feed. In the next drawing on right hand side, it is central feed this with three end feeds. So these are known as end feeds. This is central feeds. In this, it is this, and this is also coming and dividing the room into different portions. Friends, this diagram of sprinkler spacing shows you what rectangular matrix what you have to do. Say suppose you have a rectangular matrix, divide it into equal 1, 2, 3, 4. And this one, each spacing has to be not more than 4 meter like this. So you first calculate the width of the room and divide it into equal portions of 4 meter, not exceeding 4 meter. And then this you will come to know the distance d. Similarly, i- the width wise also you have to divide them into such portions so that you have equal 4 meter, or it can be 4 meter or less than 4 meter. In both the case, it can be less than or more or less than 4 meter. So you have to divide them equal portion. So this portion D and S will get decided. Friends, this particular sprinkler diagram for a rectangular area, the room over 3.7 meter but not more than 7.4 meter wide. In such cases, you have to work out the spacing, equal spacing. So it will be 3.7. Say in particular case, if the room length is 14.7, it is getting divided into four portions, five portions, three portions of equal length of 3.7, and other two just half of it, not exactly half of it, 1.8 meter this side, 1 point. Like this, you will have the rows. The rows will be like this. In the width wise, since this is diagram for a room not more wide than 7.3 meter, the room width has to be 3 point room room width over 3.7 and up to 7.3. This is the arrangement, and these two rows shows the side wall sprinkler. Lengthwise they get like this only. The side wall sprinkler row, the distance from the wall up to this will be shown in another slide to come. Okay, friends, this is the same diagram as in the previous slide with slight difference. Friends, you watch this particular drawing, which is a combined services drawing. You watch more than 1 minute, and then we'll come to know what are the elements of different systems here. And this particular drawing shows, it is a elevational drawing of combined services showing electrical, gas and fire services, and air conditioning services not shown, but they will be traveling like this. Okay, we start this drawing from the corridor. This, remember, this is a vertical elevation. First I have shown the slab, that means real ceiling, and below that the false ceiling, which is like this, and I have shown the point switchboard, electrical point switchboard. I have shown a working table which is 0.9 meter, 0.75 meter, and false ceiling height will depend upon the total height. This shows the slab, real slab and beam below. projecting. Now you can work out that I have shown a part of entire drawing on both sides of corridor, one on right side, another on left side. I have shown maximum detail on right hand side diagram. Now in the right hand side diagram, you can see that the sprinkler pipe is coming and dropping down to real fall ceiling, and after taking the profile of beam, it is going to other room. Now here it is dropping to this one. This portion is known as ceiling hank. Ceiling hank is the area between real slab and fall ceiling, and this is somewhat more hot than the room itself if the system is air conditioned. So air conditioning ducts travel like this horizontally on both sides of the beam, and it may be in the corridor portion also. Now if this hank is more than 0.85, then you are supposed to provide a sprinkler on both sides. This is the sprinkler for sprinkling water in the area, but you are supposed to provide another sprinkler just at the mirror image here to take care of any fire within this hank area. The fourth item, I have not shown any false floor. Okay, so I will repeat. This is the slab, main slab. This is beam portion, and this portion is known as hank, ceiling hank. This is fall ceiling, housing all the three: sprinkler, electrical fitting, and air conditioning outlet. Not shown here in this diagram. Design wise, there are four different type of systems. The first one is bed pipe, by far the most common, which we have been discussing previously. Then is second one is dry pipe system, where water freezing is possible in cold areas like Simla. There is every possibility of water getting frozen. In that cases, glycol mixed water is fed by fire brigade systems. The third one is deluge systems. Deluge means flood. For high hazard application, we provide a total flooding, water flooding systems. These may be water type or maybe gas type. The fourth one is pre-action. These type of sprinklers are provided in the area where there is a possibility of water damaging the surroundings, which may be very costly. Friends, we have already discussed about these two different type of system, wet pipe or dealers, out of four different systems. Let us discuss some more detail. Wet five wet pipe fire sprinklers constantly have water in them. It is the water is provided and the pressure from coming from a static water tank through fire pumps, sprinkler fire pumps. These pumps are may be dedicated specifically for sprinkler system or may get combined with other systems. The wet pipe allows for a quick reaction to a fire and is the most common type of sprinkler installed in the building. A type of building that uses the wet pipe system is high rise or office building with a few floors. This fire sprinkler system is cost efficient and requires low maintenance. Another is deluge system. Deluge means flooding type. This type of fire sprinkler system also need a smoke or heat detector like in pre-action system and any other. A deluge system has open nozzle that can be used when hazard is present. When put, when water from the pipe are spread over a floor, deluge fire sprinkler have total water falling over the area and it becomes like as if some flood is happening. In that case, buildings such as industrial parks and other with many tanks have deluge fire systems. Pre-action type sprinkler system is one of the four system previously talked of. The pre-action system is good for use in places where sprinklers are only necessary when there is an actual fire. So other items in the building don't get water damage from an accidental sprinkling. Such buildings include libraries and data centers because they contain precious information. These places contain items of high value like electronics and goods damageable by water, such as books also. Pre-action fire sprinkler system are filled with air and water is allowed to pass through when the smoke alarm or detector goes off. This type of system requires two triggers to start water flow. It helps greatly that the pre-action fire sprinkler can be set to prevent water from spouting in case of false alarm or mechanical alarm. So pre-action system has got a logic. Dry pipe system or dry pipe sprinkler system are similar to pre-action system as they use pressurized air in the pipe which adjusts before water escapes. This causes a minute delay in water discharge, what is ideal for buildings with low temperatures so that pipes don't get freeze. These fire sprinkler systems have a fast opening tool to get rid of the air and speed up the flow of water. Warehouses located in the north are a good example. North of the globe. Dealers sprinkler systems are mostly provided in large risk areas like transformer rooms. Here, pipes are not filled with the water or gas. All sprinkler heads are pre-opened. A signal from a detection device mechanically opens a water valve. Water fills the pipe and flows from all heads, so it floods the area. Remember, in case of electrical apparatus being protected, first you have to manage to make the electricity off, then only the water system should work. Dear friends, the deluge sprinkler system are provided in special hazard areas that have fast spreading fire, that is petroleum facilities, hazardous material, and electrical apparatus, and also used to apply protein and a triple F foams. We'll discuss them. Activation will cause great quantities of water or foam to flow. Usually requires several detectors to activate before discharging. Friends, this particular diagram shows two different items of dealer's system. The first one is a series of detectors which opens a valve release and valve release, and this system operates water to flow and spray water through sprinkler system. Now this sprinkler system has got a manual valve also, so that you can close or open the fire sprinkler system even if there is no signal from detectors. The location and number of detectors to alarm the signal to water to flow in a sprinkling area depends strategically. You have to decide. Friends, this particular slide shows how to restore the system after operation. The delayed clapper valve must be manually reset with the latching mechanism in the place. The detection system is reactivated. Because of this procedure, it is not recommended for the FD to restore the system. Fire department, FD means leave it on it to professional. Friends, the pre-action sprinkler details are provided here. First one, pipes are not filled with water. All sprinkler heads are of standard type. That means they remain closed. A detection device opens a water valve. Water fills the pipes. Water only flows from the sprinkler head if it is opened by heat from a fire. Water flows until shut-off system is reset. The deficiency of sprinkler system failures is due to one of the lead cause of a sprinkler system ineffectiveness occurs when storage contents or configuration change and the system is not altered to match the new hazard. Original sprinkler spacing, pipe size, or water delivery capacity might not control the new system layout. Friends, Quite often we have discussed this system, so I will not go into detail. Friends, in this diagram, the operational point of working of wet sprinkler system is explained. Let us start. There is a vertical riser system here, and it has got fire inlet connection, a water flow alarm, and from this riser system is connected the crossman's horizontal horizontal arms, maybe on one side or both sides, and these are the sprinklers here. These are the branch lines. This is the crossman. It may have different type of formations. See, the water gets out of this facility for inspectors test is provided, and they get operated through the automatic sprinklers shown here. The water supply system is shown here. It may be in the slab or on the top of this top or bottom of the slab.